Next up on stage we have Mohan, a Ph.D. student under the supervision of Professor Xiaozhe Wang in Department of Electrical and Computer Engineering. He would be presenting on employing microgrids with renewables to enhance the stability of power systems.
Hi everyone, this is a map of the state, and let's focus on the electrical distribution system there. Consider this, imagine the distribution system faces an emergency like a loss of generator. In this scenario, we have to get immediate ramping support of electricity to prevent this distribution system from outages. Our method is that we can connect the adjacent microgrid to provide this support. A microgrid is kind of like a self-sufficient electric network that has excess generation capacity. Once we connect the microgrid to the distribution system, we can transfer power to the distribution system. This microgrid can not only provide the ramping support, but also prevent the distribution system from outages. This service is called the ramping support, and this is a very key part of the emergency response strategy. The system operator has to know the ramping support capability of this microgrid in advance. However, there are many volatile renewable energies inside this microgrid. Their variability can make the ramping support capability of this microgrid not a constant value, but a distribution. The ramping support capability of this microgrid can fluctuate, sometimes high, sometimes low. Once we sample all possible scenarios, we can get the probabilistic density function of this ramping support capability. And in this case, we can choose the 5th percentile of this distribution and as a guaranteed ramping support capability to the system operator, because in this case we will have at least 95% confidence level on provide the ramping support capability under emergency. However, when there are many renewables in this microgrid, it will be impossible to sample all scenarios to get the distribution, because the traditional Monte Carlo, for example, if we use a traditional Monte Carlo simulation, and there are, it will take exponential samplings to get the accurate distribution, like 15 to the power of n to samples to get the distribution. And to solve this problem, we get a new mathematical method which only needs 15 times n samples to get the distribution. As you can see here, our method can significantly reduce the number of sampling and reduce the time to get the accurate distribution of the ramping support capability. Also, our method can identify the most volatile renewables inside this microgrid, and we can connect it to a battery to smooth out its output. Once we can do that, we can make all the distribution of the ramping support capability narrower and increase the 5th percentile. According to my simulation, we can increase the ramping support capability by at least 50%. That's it. Thank you.